Hi everyone, and welcome to this new video tutorial. We're going to see today how to create a cartoon from just a normal image. Let's first see a cartoon. I have it here somewhere. I have just to look for it. Okay. So what do we know of a cartoon? A cartoon has an homogeneous color and really clear edges. So here we have the black line that defines the head, the hair, and another black line, like a perfect circle to define the eye, and then the eye, the color is exactly the same white in each part. So homogeneous color plus real clear edges. That's what a cartoon is about. If we take a normal image, for example, this guy looking at the sea, we can see the difference. For example, the color that it's here, the tonality is different. In this one here, what is the green? I don't know exactly what color is this. Probably it's green. Here there is some sun and the green is one color. Here going up is darker and darker, and we can see many different shapes of the back of the guy. So we have to delete all these shapes, but we need to keep the edges. Let's start doing this with Opencv. We import CV2, we import numpy as np. Let's load the image. img is equals to cv2.imread adventure.jpeg. You can download this image from the link in the description, or even better, you can use your own images. Let's show the image. cv2.im show image and img, and then wait key event to hold open the image, wait key 0, and cv2.destroy all windows. And let's run this effect. Not effect. Let's run this, and this is the image that we have. Let's start from the first step. Let's first detect the edges. Edges. We have many methods to detect the edges. The most common one is Kenny. Edges is equals to cv2.kenny of the image, and then we have threshold value. Let's say let's use 75 and 150, and let's show the results. cv2.im show edges. We're not going to get into details how Kenny works. First, because I've already explained this in another video. Second, because I'm not going to use that. I'm going just to show you what's the result and why I will not use it. Edges. As we can see, first, the problem is that we have too many edges. We would like, for example, to get only the shape of this mountain, but not everything in the middle of the guy. We'll like only to get the shape of the guy, but not all the small shapes of the shirt. We can solve this problem by applying some filter. For example, we can apply the median filter to blur the image. So it will be blurred img. It's equals to cv2 dot median blur of the image and the kernel size of 5. Let's show the blur so we'll see the difference. Blur and blurred image. So this is the blurred image, and this is the edges, which is exactly the same because I made some mistake on the code. But anyway, what's the difference from the original image and the blurred? This one is a bit more blurred. So we say kernel size of 5. So we're taking small block of 5 pixel by 5 pixel, and we're going to take the median color. So for example, instead of taking all the different gradients of green, we take the average of the green between all of the close ones, and then we put that same color for all the block. Hope this is clear. And that you can see the difference from this tree to this tree. The problem, we see all the edges because we are finding the edges on the original image and not on the blurred one. That's why we didn't see any result. And let's run again the code, and now we can see the difference. The more we increase the blur, the less edges we're going to find. The thing why we're not going to use Kenny is because we would like to have thicker edges. These ones are pretty small, so let's just comment the edges by Kenny, and then we will compare them later on. And let's comment also in show edges. Let's use instead another method, and this one is going to be just a simple threshold of the grayscale image. Let's delete everything. I mean everything this part of the edges. We convert the image to gray. So gray is equal to cv2.im cvt color. The img is, and then comma cv2.color underscore bgr to gray. BGR is the format of this image, and to gray is the format of the image we want to have, and this is here, gray. After this, the gray image, we will apply a threshold, but adaptive threshold. It will be edges equals to cv2.adaptive threshold. We're going to apply the threshold on the gray image. Max value is going to be 255, so it's going to be wide. The method is cv2.thresh. Let's see what we get. Adaptive thresh min c. The threshold type is going to be thresh binary. Block size, let's work with a block of 9 pixels and the constant of 2. And let's see the result of this. And let's delete this in show blur image. Let's see the result of the edges. There are a lot of edges. Probably too many. cv2.im show. I want even to show you the gray so that I can explain how it works. So starting from this image, we got this one using the adaptive threshold. The adaptive threshold it takes really small areas and find what to convert to black and what to white. We need, even in this case, to remove the noise. So first, we could use the filter. So gray, it will be cv2.media at median blur of the gray, and then the kernel size of 5. And this is an operation that will already clear the image a bit. And that's something. Or let's try to increase the area that where we're going to find the threshold. Let's say 11, for example. Let's still increase it and we'll see what we get. We get only thicker edges, but nothing else changed. Probably the take-home value. Let's keep 9 and let's increase this one to 11. Okay. Exactly. The more we increase the second number, the brighter the image is going to be. So this is actually a nice result. That's maybe a bit less. Let's keep it this way. For the moment, we can say that we have a sketch of the original image. Now what we have to do is to put the color inside. The more homogeneous the color is, the better it is. So this one is edges, and it's the first step. First edges. First, it's not okay. Sorry. First edges, and second color. How can we make a color homogeneous? We can make it using the blurring filter. So it will be, let's say this way, color is equals to CV2 dot. I'm going to show you the median blur, and we'll see why it's not good method to use of the image. And let's make a really big kernel. The bigger, the more cartoonish effect we're going to get. Let's say 21. And I forgot to show the color. Let's not show anymore the gray. Let's show only edges, image, and the color. See to that image show color, and then color. Let's run this one. Okay. Actually, it's not as bad as I thought it would be. So even medium blur could already be useful. This is the color. Usually the problem when we apply the blur is that it blurs also the edges, so even if this part looks let's say cartoonish effect, but still we lose too many details. So here, for example, on the branches, the edges are not really clear. We want to find some blur that keeps both edges, but at the same time can blur the color in between. And for this we have the bilateral filter. So instead of CV2.median blur, we're going to use CV2.bilateral filter of the image. Sorry, I forgot which values we need to pull of the image. And then let's say 9. This should be the block size. Then we have 2 threshold value. The more we have this value higher, the more cartoonish effect is going to be. If they are too high, we're going to lose quality of the image. So we need to find the best value that fits for our image. And here is an example. This is the image with the cartoonish effect. If we see with the original, it's a big difference, but still it's good because it keeps it keeps many details in comparison with the median filter we used before. Let's try to increase these values to 350, both of them. Now probably we're going to lose a bit of the details. 300 and 300. Anyway, now for this, let's say that we are both satisfied with the color and the edges. The final operation we need to do is to mix both these two images, so the color with the edges, and we will get our final result, the cartoonish effect. So this is the third and last step. Third cartoon, it's equals to cartoon is cv2.bitwise, and this is the bitwise operator that we have seen in some video tutorial of the series, Opencv tutorial, to connect two images. We have a black and white one and a color one. So we have the edges and the color. Actually, we could do, okay, let's try this way and then we will see edges and color, and let's show only the original and the cartoon. cv2.im show cartoon and cartoon, and let's run this one. We get an error because I did an error. Bitwise and it will be equals to color and color. So we have two images, color and color, plus a mask. Mask equals edges. Let's explain this. Let's first see if it works, then I will explain it. Makes sense. Okay, this is the result, but let's first understand what we are doing. We have cv2.im show color, and cv2.im show edges and edges. It's this one, color. We have with the bitwise operator, we are taking this image, the color, so we can see color, and again the same image. It's to connect two images together, but we are using the same image with one exception, that we are putting a mask, and the mask is edges, and exactly this one. We are allowing connecting two images to show everything where in the mask is white, and we are covering where the mask is black. So we show everything, and somewhere here I should have these images are too big and I cannot find the okay, this is the final result. So exactly, we show everything where it's white, and when the mask is black doesn't show anything. So that's why we have these lines. And this is the final result. Unfortunately, I'm messing around right now with these images because they are too big on my screen. And now you can see the difference. Let's put it this way so it's more clear. You can still improve the code or change it. It depends how you want to have. If you want thicker edges, if you want more homogeneous color, that's up to you by changing the value of the respective part or the color of the edge. Hope this video is clear. If you have any question, just leave it on the comment.